Specifically making sure that we were able to run the sessions right from an always free account, and it looks like the person was having problems with Python scripts, right, or hanging and then getting a running out of compute resources, right? So there are a few things that we can try and test. So what I did was this morning I created a brand new always free account for myself, and I was just running and testing that for you guys. So I'm gonna go and jump into that right now, and then just to make sure, right? This is a brand new account. I have basically no notebooks here, right? This was the first notebook I got. Was I opened an example notebook. I went in, and I think I showed you guys this last week, right? I went into examples. I selected this one, which I know it's probably the most complex or takes more resources to compute. And I then loaded that right into create a notebook. I gave it a name, and then that's what I loaded into my my notebooks right now. So in there, I just have been to that notebook right now, and I executed them, right? So all I wanted to make sure you guys see is that you can definitely run a Python, right? The Python code is going to run, and I just ran this. You can see here 20 minutes ago, right? Or less than 20 minutes ago. So I was able to import libraries. I was able to then create a wine table, right? And run this component here in Python, and then run the AutoML components, right? So we are expecting that these guys are going to take more time, right? So when you do AutoML, even though the data set is not large, right? But the way that AutoML does things, right, which is trying to identify, find the functions and try to identify what's the best model, right, to use, is going to take some time, right? So it took 45 seconds, which is not a lot, but still, it's not immediate, right? But that's something that is probably going to be normal. Then we have the automatic feature selection, right? And then again, both on the classification and regression side, we end up getting around 50 seconds, right, in this case, and 41 seconds for regression. Now, remember that you can put the parallel equals here, but this all depends on basically a couple of things. The first thing is, if you're using low on your own component, right, even if you have a 16 CPU, 32 CPU autonomous database, it does not matter, right? If you use low all the way up here, when you click on the interpreter binding, right? If you use low, right, and to use that, basically you drag and drop it up to the top one. So what the OML notebooks is going to do is going to select the top one, right? The first one that it sees that can process Python, and it's going to use it, unless it's unchecked, right? So you got to make sure that it's checked. And then if you have checked all of them, again, it doesn't matter, right? The order in here is that the one that is going to tell what to do. So if you use low, right, and you have only, and even if you have 16 CPUs, 32 CPUs, you're going to be basically not multi-threading, right? The basic process for you, we're going to give you one CPU, and that's what you're going to get basically for running. So when you go into the Python portion, it's still going to be a single threaded. It's going to run one CPU. It can run several processes at a time, one after the other, but it's going to be a single threaded thing. So if you have more than one CPU available, remember to try to use, medium or high. Now, these depend as well on the number of or the volume of data, right? So if your data is tiny, what we have seen in practice is that the high actually might hurt you, right? Might hurt your process, depending on the type of processing you're doing. sometimes if you go high, so you're asking for larger parallelism, and if you have that available, the database is going to try to give you more parallel threads, right? So that there is a little bit of time while the process tries to split your processing capabilities, right, into all these threads. And if your data is tiny, it might not really help you, right? It might actually be bad for you. So I would advise you, if your data is large, yeah, sure, go ahead and try it with the high, right? We are doing some more testing, especially after that question, right? Because and again, in the free tier, right, in the free always free account, we're going to be doing some more testing on volumes and some more testing on settings, because one thing is the high, low, medium here, right? So the priority, what I'm doing is I'm just leaving high there, right? So that's the one that's going to command, right, this process. And then the other portion of this is the parallelism you're asking for here, right, in your text. So again, this is also dependent on the level of parallelism of the table. So I can come here and say, oh, give me 256 parallel for sure. So I can ask whatever I want, but this is limited to the parallelism on the table, the parallelism that the DBA gives you, right, access to, and also the number of CPUs that the database has, right? So you can't just have, like myself here, an always free account with one CPU, and I would love to have 16 CPU, 16 parallel. That's not going to happen, right? So there are a few things, again, that it's important for you guys to have in mind. And then I did I just ran it entirely, right? So the model tuning takes more time. So I can ask parallel to whatever. You guys can test different types of levels here as well. And then, and this time I took 2 minutes, 8 seconds for classification, 2 minutes, 11 seconds for regression, right? So we are aware of all these kinds of processes that you might, try to find some different types of algorithms and models that will take you a little more time, right? So finally here, we have a search space for this best model. We're taking 1 minute, 35 seconds. And on the right-hand side, you're taking another 1 minute and 12 seconds, right? And the model selection, which actually is the guy that does everything at once, right? It does all those components for you. And again, it's 58 seconds and 56 seconds, right? So what I wanted to make sure that you guys understood was that depending on what you run here, right, is what you're going to be able to see on the database itself. So for example, if we go back to, if I go back to my account and I go back to the autonomous database specifically, right? So I go back here, go back to my autonomous data warehouse, and okay, so that's my guy here, right? Always free. So I go in there and I actually can, right, click on Performance Hub, right? So when you are on your account, on the always free account, you click on the Performance Hub and it's going to show you, right, what is the usage. So I can come back here, right, and take a look at what was I doing, right? What was that exact computation, right, doing there? And because I can see here the maximum threads, right, I can check this box. It shows me in red what's the maximum threads that I have available, right? So I am definitely using the CPU to the max, right, on my environment here, right? And you can see I selected high, so I was running everything in high, right, at that point. So there is some interesting things that you guys can do here. So you can see the different components. You can see that I'm running Python, right? This is the Python sessions that I was executing. And you can see the SQL ID that I was running. And there are some capabilities for finding, some of these information about that model. So I click on that query, right, or that SQL, and I can see what was, the execution of that. And I have some information about the analytics, right, of that. And I can see here the, the hash, right, information of that. the PL SQL that was executing, and things along those lines, right? So there are a few things that you can, right, see. You can see the query that behind the scenes runs, right, for you. So there are a few things that you can look, and that might be interesting for you to dig a little deeper, and if you're interested in see exactly what's going on behind the scenes. But in this case, that's it's going to be a very simple thing, right? It's going to be a very simple process. So you're not going to explode your memory that easily, right, in here. But the question exactly that we had from received right from the web was that there was some sort of a problem, right, in memory. So there was some explosion in memory at that point. So that is again, it's not part of the SQL, right? It's not going to be your autonomous database running out of resources, but that is going to be your Python session itself. So one thing here that you guys see is that I'm running these small tables, right? So I take the table from scikit-learn, right? And then I load it in memory in that Python session. And then immediately after that, I push that table to Oracle database, because I know that now I'm going to use my algorithms on the database side. Now, you can imagine if you try to, from your own components or from an Oracle database that is large, if I actually do an OML sync, right, into that table that is large, and then I do an OML pull, what's going to happen is then I'm going to fill the Python sessions memory, right? And that starts filling up and filling up. So if I am not careful, for sure, in this case, because we don't have a we don't have a control right now over the size of that machine running behind the scenes, I'm not going to be able to say, okay, let me use more memory, Python, please, right? So that's going to be tied to the size of your account, and again, the size of these guys, right, the interpreter bindings. So when you use high, we are going to try to give you more memory on that Python session, right? But again, because it's an always free account, is a one CPU, you're also going to be limited to that, right? So the information that Oracle Machine Learning is going to give you, right, the feedback might have to do with you ran out of memory because your Python session was running on low, and then you might want to try and switch to high. So I would advise you to try to do that. But again, the size of that Python memory is not huge. It's not going to be gigantic. You're not going to have a terabyte of RAM there, right? So it's not going to, you're not going to be able to pull a very large Oracle table into a Python to try to run your open source, scikit-learn algorithm on 1 billion records, right? That's not going to be possible in this way, right? With the platform the way it is. So I think that's what I wanted to comment on today, that related to that question that we had before, and then so again, Python, as most of you guys know, I think it's now the Oracle Machine Learning for Python is GA, so it's going to be available in any autonomous database. So in autonomous database, this is a just created this morning account on an always free tier, and I can use my Python and I can run my Oracle Machine Learning for Python components, including the AutoML and things like that, right? But again, you got to make sure that you're careful with that pulling all the data into memory. And if you have any doubts on any issues, you can try and test all of these. So everything that has OML for Pi in front here is related to that. So it's not only these 5 labs or 6 labs here, right? But you have everything else, right? Anomaly detection, clustering, classification, data transformations, data cleaning, and you have pages and pages of examples, right? So page number 2, you even have text mining, feature engineering, partition models, REST APIs, anomaly detection. So So then from the Python here in text mining, you jump into the SQL versions of these examples, right? So then you have all the examples again, but using our SQL APIs, right? So I think that was it on my side, and I hope that was useful. And again, I'm opening for Q&A, and then I see a few questions were already answered. Thanks, Mark. Do we have any others? Let's see here.
Yeah, we've got one coming up here. I know it's not possible at this time to upload regular Jupyter Notebook and then work on it directly or convert it into OML Notebook. Are there constraints that we should be aware of if we are trying to run the regular Jupyter Notebook by copy-paste into an OML Notebook and run it? Any changes that are needed?
Okay. Yeah, I think that's a great question. So one of the issues you're going to find, right, when you go into a Jupyter notebook and then you try to convert it or translate that directly right into here, is I would say that the one issue you got to be aware of is, or let's say there are two that I can think of. The one is the data, right? Where is the data? Where are you pulling the data from, right? I think that's going to be one of the issues you're going to make sure that you're going to find potentially here. Remember, this is the autonomous database behind the scenes, so you definitely want to be able to pull the data from a database table, right? Preferably, if there is data on the object storage, you can actually also create a table and point to that data. So there are all different methods and ways to pull in data from your laptop, right? CSV files that I showed the last time. And things along those lines. So whatever you do in terms of data and pulling data in is one of the things that I think you got to pay attention when you're trying to run or copy paste to Jupyter. The second issue you're going to have is packages, right? So I think that's all the other component, right? So on our side here, you see I do an import pandas, we do an import OML, we import OML, AutoML component, right? And then we import scikit-learns, right? So those are some of the components we have. We have matplotlib as well and a few others, right? But we don't have all of the components that you might want to have. So if your Jupyter notebook is using algorithms from different packages, right? Or packages that we don't have access to right now inside Autonomous, then your code, is expected to fail. So that's all I think it's an important thing that you guys got to be aware of, right? So if your code in Jupyter has a import from, I don't know, TensorFlow or something other like that, right? Then you definitely are going to see an error here.
Okay. And there was another a question about sizing as well, Marcos. Looking for guidance on sizing of ADW for a typical machine learning workload. A customer has a team of 10 data scientists. How can ADW shape bring your own license be determined? Is it recommended to have one OCPU notebook per data scientist, and how the exadata storage be estimated? I highlighted that we have a blog. I posted one a few months ago on autonomous database performance benchmark that we did that highlights how for model building, concurrent model building across multiple users, and seeing how that scales for different data sizes as well. And I think we touched on this question in one of our previous sessions too, because it certainly is one that it's an important one to be able to address. But there is a great deal of variability depending on what the users are planning on doing. Are they going to be building with one type of algorithm more so than another? Some are more compute intensive than others. Are they going to be pulling data into Python to make use of certain Python packages, as Marcus was just identifying, that we have available in Autonomous? And so these types types of differences in how the product will be used certainly would impact what you would want to have for sizing guidance on that. So it's not a one-size-fits-all kind of recommendation. I mean, to get started, I think, as Marcus is showing the blog post here, it might give you a better idea as to what to expect for concurrent users. I mean, we're looking at what are the top 7 factors affecting performance. And then when you have autonomous database, how can you leverage that to the fullest? Here we're showing 100 million rows of data up to 800 million rows, and how different algorithms compare. Certainly we have linear scalability, but at one level it's also what is the performance that you wish to get or wish to have for certain users, and that can affect, do I have a 16 CPU? Do I have a 32 CPU? Do I have a 2 CPU? Autonomous database supporting this. And this one here in particular is very nice, highlighting that as you increase the number of concurrent users, what's the impact on what those users will experience. And here that we're comparing autoscale versus no autoscale. And we see that with autoscale, where we're getting this benefit of up to 3 times the number of OCPU that were originally configured for the system, and this is done dynamically for you. You don't have to do anything other than flip the switch when you configure the database. You will see better performance for more concurrent users. So I think these are the types of things that you want to be looking at, and the features of autonomous database that really make this environment quite good for concurrent users, giving you a lot of flexibility in how you configure the database and work with concurrent users. Marcus, anything do you want to add to that?
Yeah, I think that's definitely a great comment, Mark. And one of the things we did as well, when we asked people, right, to join our Oracle Machine Learning for Python lab, right, live labs, we had probably 100 people concurrently, right, running our different things. And I think that was also a great experience where if you're correctly planning this thing, you can probably get people helping you guys visualize this component. So for example, I had, in this case, you can see my screen, I had like 5 different databases, each handling around 60 or so users, right? So you can see, the amount of workload and the processes running there, right? Of different users that depending on the time of the day, right? People running different things, right? So and here, something like in this case, you can see the different customer groups, right? Some people running with low, some people running with medium, right? So I think that's something that the environment allows you to even have a deep knowledge, right, from the specific set of users and the workloads on collaboration. So once the data scientists are running these things, right, then the database team, the administrators can actually have a very specific look at what the workloads have been, right? So that's a great tool for collaborating with all the different teams that are running several of these components as well, so that people feel more they can feel more alleviated that you can actually handle all of these different right sets of users here, and you can see the users running things, right? So hopefully that helps answer it. I think we have another question.
Yeah, this one is also has to do with compute resources, and I think, as Marcus was highlighting, that depending on what you're trying to run and the data sizes you're working on, one OCPU and the corresponding resources on the Python side may not be adequate. However, we have used all of the sample programs extensively in the single CPU setting, and so you should be able to do that. We're looking into possibility that what might be going on with the Frankfurt data center, and so we can get back to you. If you can provide us more details, send me an email, mark.hornick@oracle.com, and I'll be happy to look into that with development for you more specifically. We'd want the OCID as well as the database name that you have. So please don't hesitate to check with us on that.
So thank you very much, guys. I think we got to our the end of the call today. Again, I really appreciate you guys coming in, and please reach out to us and send us questions, right, as well in the Ask Tom session, right in the Ask Tom interface. You can send us questions there, and we'll be glad to answer. So until next time, on this Thursday, we are going to talk about Oracle Machine Learning Services, and I'm going to be doing a demo and talking about it. It's currently on limited availability. And then next week on Tuesday, we're going to have our weekly meeting again. Thank you very much. And then we're gonna still be online. Yeah, we're gonna. I see the question. We're gonna share some of that links, right, to the OML tutorial.
Mm-hmm. And is there a way to leverage the data science platform on Oracle Cloud along with OML in ADW capabilities? Are they totally independent? So at the moment, we have just released OML for Pi in Autonomous Database, and we will also be releasing a client package that can be used. And once we do that, the idea is to have that interoperability between the OCI data science platform and the database, so that these two tools can work together more so. So I would say look forward to that. We're not giving any dates at this point, but it is definitely on our roadmap to make that happen.
Right, and one last thing is that I guess Kaisar is talking about the machine learning tutorials. What I wanted to say as well, guys, is that on our GitHub, we just changed this thing 6 days ago. So if you had downloaded the labs before, please make sure you update those, guys. So this is the link to the labs. We have revamped them, changed them. You have a lab 0 that you got to run on your account. Even if it's an always free, you got to run that to create the tables and grant, and then you can run all the labs for you there. So I'm going to let's see, answer that to you, Kaisar, in that, okay, in the Q&A. So that's the link to you guys. But in any case, I think that's it. So thank you very much, guys. Thanks a lot, and talk to you guys later this week.